Hi, and welcome to Q's Workshop. Today I'm continuing on the WigWag engine, so this is part 4, and today I'll be working on the crank disc. So there is two designs provided by Ade Swash, so the original and alternative. I'm going to be doing the alternative option. It does seem a bit easier. It's just when working through the order of operations and so on, I've kind of figured out how I want to do the alternative design, so I'm just going to go with that. So I've got a piece of brass stock here. This is 40 millimeters in diameter. I've measured it. It's literally just under 40 millimeters. I still want to clean it up a little bit, so I'm going to end up with it being a little bit shy of 40 millimeters. But yeah, let me get this into the lathe and we take it from there. Alright, all set up in the lathe now. I'm just going to start off by facing it, getting that cleaned up, then do the diameter. I'm literally just going to take enough off the diameter just to give it a uniform surface finish, and then we'll take a look at the features that needs to be cut into the face. So I'm just going to get some marking blue put on the front here. I'm then just going to take a center, just see if I can put a little divot right in the middle, and then I can use that to just scribe out some lines for kind of indicative markings of where I'm going to work towards and from. I guess on this drawing, it doesn't provide really the details on how deep it needs to be. This center piece here, you work that away, but it doesn't actually say how deep it needs to be. We just end up kind of with one of the sides as 7 millimeters thick, and then the side is 8 millimeters, which is just different to the previous version. The previous version, it was 10 millimeters. Then we've got a 9 millimeter section, and then 7 millimeters would be kind of the whole depth of this piece that we need to cut down. So essentially cutting down 3 millimeters. But here it doesn't really show it. So I'll probably make that about a millimeter, maybe 2 millimeters deep. But yeah, I guess it's just for visual effects, and it kind of creates a little bit of weight on this outer section here for to keep the crank spinning. Alright, so I've got I've got the lines that I'm going to be working in between now. I'll move the camera, that's kind of a better shot of me cleaning that up. But it will have filleted edges from there, cleaning in about 2 millimeters in depth. Alright, so I went 3 millimeters deep because I'm going to be cutting a section of 2 millimeters off on the one side to give the 7 millimeters and the 8 millimeters, so then it will still be 2 millimeters deep on that 7 millimeter diameter side. The front edge of the tool, the bottom edge here of the tool was rubbing against the side here, so I couldn't exactly get a perfect finish there on this outer edge. And I'll see if I can clean that up. Right, so that's all for these features. So the outer edge here, I didn't exactly get a very nice surface finish because this under edge of the tool was rubbing here at the bottom, but I'll clean that up. I've drilled a undersized 6 millimeter hole, which will get basically reamed, but just with the front edge of the reamer. As per the build notes, just use the front edge of the reamer just to clean it a little bit, because this hole needs to be a press fit onto the 6 millimeter axle. So using the lead in of the reamer will keep that hole undersized, which then should result in a press fit onto the axle. So I'll leave that undersized for now. I wanted to drill the hole before I take it over to the mill, that I can use that hole as the reference point, and then from there we'll work out where the other features needs to go on the mill. I'm just going to try and clean up the inner piece here. So I've just got a home ground bit in the front of a holder. So this is usually a holder for threading bits. So like these 60-degree bits would be held in there. So I've just got a flat-faced one ground that I'm going to see if I can clean up the inside there. Right, I think that actually worked better than I expected it was going to. Alright, so let's get this into the mill. Alright, so we're all mounted up in the mill. So I've just got a little homemade V block here, which I don't know if it's perfectly aligned, the V with the edge of it. So what I've done is I've just used some parallels, one on the top of my part, one on the top of the vise, then just to make sure that the top of this is level. I've also then found my center using the drill that I used to drill it. So that is now perfectly in center. So if we just look at order of operation going forward, we've now found the center here. I'm going to move up my 15 millimeters. I'm going to drill the 4 millimeter undersized hole, because again, this the crank pin that fits in there has to be a press fit. So I'm going to drill that undersized, and we can sort out the size with again, that lead edge of, or lead in edge of the reamer. So we'll keep that undersized. I will then come and clean up. So this, the top section of this, so that 20 millimeter top section has to get cut down by 1 millimeter. So we're going, essentially the crank disc will be 8 millimeters, but we're cleaning 1 millimeter of that top section down. Once that's down, we will then come in and clean up these two pieces over here. It says here that we need a radius of 12 millimeters, this corner. If I read that correctly, I need a 24 millimeter end mill, which I don't have, and I'm not going to take the boring bar out to do that. So I'm going to use a 16 millimeter end mill, which is a radius of 8 millimeters for this corner. I think it'll be fine. I mean, that's really just for aesthetics more than anything else. One thing that I am keeping in mind is just this little piece around the axle shaft. This top piece must still be the full 8 millimeters, that edge over there. So I must just watch out that I actually don't cut that piece down there. So I'm really just taking this top edge around there and taking it down to 7 millimeters and skipping this little piece in the inside here. Yeah, first drill, then we'll clean up to 7 millimeters, that top part, and then we will cut down these edges. That's it. Right, we're back at the lathe just for the final parting off. I've just got a live center in here just for a little bit of support, because it is sticking out a bit far due to the size of the material. But I'm just going to take it easy, nice and slow, and then once we've parted that off, it's literally just cleaning up the edges a little bit with a file. Just slow this down a bit. Right, so let's just get that little piece cleaned up there and then just face this back lightly, and then we should be done with it. Right, perfect. So also, when I mounted this, I just used parallels at the back here to make sure that it was flush, or at least straight on the back. So yeah, they are. So they were slipped in here at the back, just to make sure that it's level. Obviously at the top it couldn't, because this inner piece has been cleaned up by a millimeter, but I did put them on the bottom. Right, there it is. Just going to clean these edges a little bit with a file, make them a bit softer, and I'll get you at the workbench. 1, 2, 3. Alright, so that's it for today. I think this came out really good. So I took it out the lathe, just took the burrs off, cleaned it up with some very fine sandpaper. It's got my fingerprints all over it now, but it cleaned up really nice. The only dimension that I missed was this one over here. So that was meant to be 15 millimeters. I've got it on 16. I left a little bit on the edges for a final pass, and I never did the final pass. I kind of cleaned up the final pass on this bottom edge, and then when I went up on that same dimension instead of moving over slightly. But it's neither here nor there. I don't think that's going to matter that much. But if it does, I can just come back and clean that up later on. But yeah, that's it for today. So the next video will be the piston, so please keep an eye out for that. Thanks for watching, and I'll catch you in the next one.